So this is part 2 for displacement and average velocity mini lecture. Just to recap what we talked about during the first time, we had tabular data indicating how a particle moves, which we sketched in with a motion diagram here, and which we plotted in an x versus t plot right here. And we calculated the average velocity over the 0 to 1 time interval, 0 to 2 time interval. These were both positive. Whenever you have average velocity positive, it means the displacement is positive in the right direction in this case. We calculated the average velocity over the interval time from 2 to 3 seconds, where we got a negative average velocity, and that's an indication that over this time interval the displacement is negative. You can see it right here. That's a negative displacement. It's a to the left displacement. And then finally, and perhaps most surprisingly, we calculated the average velocity over the time interval from 0 to 4, which is 0 meters per second. And that's a reflection of the fact that the sum of these 4 displacement vectors is 0, which is what you see in the numerator here, and which I diagrammed with this magenta algebra that we talked about during the last lecture. And so now I'd like to finish up with one of the kinematic equations. And to generalize what we've done here, we can write that v average in the x direction from 0 to t, so let's assume we start at time 0 and go to time t, is going to be equal to x of t minus x of 0 over t, which is going to be x of t minus x naught over t. And so this x naught is just really another way of writing x of 0, subscripting the 0 instead of putting it in function notation as we have right here. And now we can rewrite this. We can take this expression and this expression and abbreviate this a little bit. So let me first of all rewrite it just as v_av in the x direction is equal to x minus x naught over t. So if we multiply through by t, we get x minus x naught equals v_av in the x direction times t. And finally, x is equal to x naught plus the average velocity times time. And that is one of our kinematic equations. So we started off with this definition and we ended with that.